Hi everyone, this is Marshall with Marshall E. Campbell Company. I'm the sales manager. Welcome to another edition of one of our webinars for Tools of the Trade. With me today is Philip Mondro with Fluke. He's going to give a presentation today on some power monitoring that'll help you save money in the long run. With that being said, I'll turn it over to Phil.
Good afternoon, everyone. Hope you can see my screen here. And I'm just trying to make sure you can. So,
You can see it, Phil.
Excellent. All right, well, let's get started. We got up to an hour here, so thank you for the attendees that here have joined. There's a couple different ways I want to approach this. One is, energy in general is expensive. Everyone's got a different standpoint about how they feel, philosophically about green energy. I think there's one truth going forward is that energy will be more expensive, likely in 2021. And so there's a couple different ways to mitigate energy consumption. I'm going to talk about that today in a couple different parallels or examples. And if I'm successful, I pull this off today. I'll talk about it residentially as it applies to us, kind of personally at home, but I'm also talking about it at work in an industrial setting. We will cover the Fluke Power Quality Portfolio. One of the things that comes up often is, and it might get asked today, is which meter is the right one for me? And typically, we encourage, obviously you work with your distribution partner. Marshall E. Campbell is a very strong partner with us in this segment, so I encourage you to reach out to your Marshall E. Campbell person that you normally talk to. You can obviously talk to Fluke here directly. And again, I want to thank you, Marshall Campbell, for setting this up today. So a little bit different setup. I'm trying to make sure I can drag down screens on my desktop and see hopefully that they populate correctly. And I think it looks like we're on the path here. If I'm looking at the audience view, you guys can see some fancy graphs on the screen. So I think we're making progress here. Again, hopefully you guys are doing great at home. Your family is healthy and safe, and we're going to talk about power quality in the ways you've maybe never considered before. On my screen is a consumer's energy portal login. Now, the significance of this or the interest would be specifically my own individual home. You can see year over year, 2017 in yellow, 2020 in green. Actually, 17 dropped off. So blue, 2018 to green in 2020. Even though we've been home, I'm still trying to reduce energy year over year electrically. From a natural gas standpoint, I've been trying to do the same thing. Now, a lot of caulking, a lot of thermal guns, a lot of yelling at kids to turn the lights off, and some LEDs here and there. But what I would encourage you to do, whether it's Detroit Edison, primarily in this market, or Consumers Energy, is use the tools we have in front of us. Consumers is very nice, as well as DTEs is very nice. So take advantage of becoming more familiar with your own energy footprint. And this translates immediately into absolutely being a champion for power consumption at work. All right, so here's just a quick example. I thought it was, everyone seems to love charts and graphs, so that's why I put it up here. If you are a social media, if you like social media, I've got a bunch of feeds under my profile. One of the things we're looking at here would be, I would say, an example of Corona, and usually that pairs best with lime in a beverage. Now, there are differences between Corona and partial discharge. We'll talk about that as it relates to power consumption. But this would be an example, a visual example of when you're near some electric wires and you kind of hear a buzzing sound when it's humid or a little bit foggy, and we're able to now visualize that. We'll talk a little bit at the very end about like the Easter egg we have for you today with a special offer, as well as the Fluke i900, i910, which we're showing here on the screen. So we'll put that one away for a moment. Try another screen here to see if we are successful. So far, so good. Okay. So Fluke Connect, is a cloud-based platform that all our tools will talk to. It will talk to some CMM system work orders, a system of record. What is the work order system you use to, track and administer the activities in the plant? It could have asset management. E-maintenance is a Fluke-owned company. And the nice thing about that relationship is that the Fluke Connect tools will marry right nicely into eMate. So if you're searching for a CMM system, or just trying to organize your data, that's a really nice platform. There's also a Maximo bridge with potentially N4 and SAP connectivity coming in the future. So a lot of that's there to make entry and organization of your data very very streamlined. Now, this example here is not three-phase. It happens to be Phil Mondro, his basement here. So I've got a 3540 logging meter monitoring my electrical main panel in the basement with the cover off. Now there's a picture I have of it. So if you use your imagination, the gray panel in the basement, safely pull off the panel, safely hook up the current and voltage connections, and voila, we have voltage. Now, I will attempt humor in the fact that I don't do it very well, but I'm trying to get better. As everyone knows, typically what, there's left and right-handed scissors, right? As we all know, probably someone that shouldn't hold these and run with them. The danger of electricity is significant. So many of us have gotten shocked inadvertently in our lifetimes, playing with outlets with paper clips when we were kids, or an extension cord that was bad, and it's no fun. Now, when I talk about power quality, measuring electrical power, is your safety is the first and foremost concern, and especially in an industrial work environment, thou shall and must follow all safety protocols, typically hooking up equipment when de-energized, wearing the necessary PPE, and following any and all safety protocols that you're supposed to from a work standpoint, non-negotiable, because we want you to be around for a long time and we don't want anything bad to happen to you. So I'm saying that as a reminder, is just because you can hook up to your panel at home doesn't necessarily mean that's a good idea, and you might want to have a qualified electrical worker doing that, especially if you're not trained and comfortable or knowing the dangers. It doesn't take a lot to injure us as humans, and the last thing you want to do is have a bad day. So enough with the safety message. I just want to make sure that I set it out there because it's important. You'll see from this graph, and we use some very simple examples of, my current single phase voltage is 123 volts. The max it's seen right now is 124, and the minimum is 122. You can see my current draws for both phases. The max is 18, the minimum is 3 on one leg, and on the other leg, it's kind of doing the same thing. The nice thing about the Fluke Connect free software that's online is we can essentially log in and we can see the activity at our home in real time, much like we could with kind of like the consumer's energy, but it's not real time. Now, when I was getting ready in the morning, blow drying my hair, well, actually my spouse was, because she's got really nice long hair, is there would be a consumption of energy being increased. Now, I can turn on my furnace because I have a Nest app here at my disposal, and we could potentially see a change in amperage, and we'd likely see a reduction in voltage on the charts, on the charts and graphs. So thermostat is turned on, and let's wait for a moment and see if we see anything terribly exciting. Now again, we're under volts, amps, parts. We've got a couple different field trips that are quite fun. We've got active power, power overview. Wait for this to refresh. That takes just a second. And we've got total harmonic distortion. Typically don't worry about total harmonic distortion in a residential setting, but there are things that kind of cause problems potentially. So I can hear the furnace is turned on. We are going to scroll on here where we can show the current and picking the right phase or giving it just a second to refresh. Let me try this one. Okay, a little bit of internet pokiness. I got a pretty good, oh, look at that. There we go. So there's the furnace, essentially drawing energy, and then we'll see it kind of fall off, which is typical and kind of like a rise and a fall, or a cup and a handle approach. That's important from an industrial standpoint, is when you have 100 machines in the plant and it's 6 a.m. or 4 a.m. or whenever you start up or warm things up, if there's not a cultural understanding that turn everything on within 1 minute, it's going to have a pretty dramatic impact to the amount of power you're drawing in all at one time. Now, the local utility that provides you power absolutely loves the fact that you do this, because they plan and rate you according to how much you pull from the system. And one of the things that's on the bill, and I guess the one of the freebies today, and I guess I'd call it common sense, but I'd also say, if there's questions along the way too, I'll ask Joel, just type them in the chat, so go faster, go slower, list them in the chat there. So everyone that's on here, I really appreciate that. Where was I going with this comment? Know how you are billed at home residentially, and know how you are billed at work if that's in your area of responsibility. Now, I just recently did the math for my own residence. I live in the Lansing area. I'm at about 16 cents per kilowatt, all in, all the fees and all that stuff, and that doesn't include the appliance rebate program we pay to fix the washer if it breaks or something. So what's coming in 2021 is time of day or time-based billing. So what I'm seeing is like between 2 p.m. in the afternoon and 7 p.m. in the afternoon, we are going to get rated. It's going to be more expensive for us energy consumption wise compared to in the evenings. Now, if you have an electric vehicle, usually you're ahead of this having a recharging friendly electric rate plan, which means you're probably going to charge after 11 p.m. or sometime in the middle of the night where energy is less expensive. But make no mistake, the utility is okay with using as much energy as you possibly want. They will absolutely let you take it. It's kind of like having a cell phone with a data plan and a teenager, where it's like, if they're using up all your data while you're on the road traveling, you might be dinged for extra fees. So I guess the bridge that I got really excited about from a power consumption standpoint was when I took a personal interest in my own energy footprint, or the consumption of my own energy at home. It absolutely correlates into the enthusiasm and the need for, energy observations at work. We can scale this from the energy coming into the building, and then we can kind of start moving downstream into branch circuits and specific pieces of equipment, and then we can make conclusions that would indicate maybe we should upgrade this particular motor or process to something more efficient, or maybe we shouldn't turn everything on all at once because our bill is crazy. Now, it was more than a year ago, but less than 2. I had a client in West Michigan, and they bought a 438 power logger from us, and we were doing some follow-up on it. And I asked him the question, like, how are you rated from the utility? He goes, I don't know, let me check. And the simple fact that we did that conversation is it netted that company a $43,000 rebate because allegedly the rebate, the utility, which will go unnamed, forgot to tell them that they made a mistake on their bill, or forgot to tell them that they changed the way that they're rated, and ended up paying the end user $43,000 back. And I think that was, someone probably got in trouble for that. But no, it's your own responsibility to know how you're consuming energy. And I think, now more than ever with, solar and wind and green choices, all of us tend to be more familiar with that, what's out there. But at the end of the day, we can only really control in our own individual houses, as well as, be a good steward, for generations to come. A little bit of soapbox there, but relevant. Now, if I had this session logging longer than this from this morning, we would see a lot more data, as well as kind of the ebbs and flows of the household here, with an oven turning on, microwave, furnace, lights going on and off, a little bit of humor, hair dryer and curling iron going on. One of the things I found was converting my electric dryer to a gas dryer made not like a $30 per month change in my electric bill reduction wise, and that was a really good investment. Now, when we talk about power, we kind of start with, what's going on voltage wise? Do you have good voltage coming in? Is it balanced? And we don't always talk about over voltaging, but it's also very important depending on where you're at geographically. So a lot of things industrially are not designed to run on, more than 480 to 485, 490 volts. And when they get popped with a 500 volt peak for an extended period of time, they don't like it. And the good news is you got a great distributor like Marshall Campbell that'll sell you more things to replace it with. Now, a transient, slightly different, where it's a momentary burst of energy. It could exceed 10,000 volts, 15,000 volts, which is why we have multimeters and things that protect us in the event that a squirrel decides to jump on a wire and short itself and turn into a not alive squirrel. And that sends basically a spike down the line to the path of least resistance, so to speak, and where it might go, we never know. And that's why we are always concerned that just because there's 120 volts, normally it could go up to 600 volts or even more at any given time, and you just don't want to be touching the circuit at that time, which is not ideal. Now, I want to put this screen away for a minute. We'll come back and see if there's anything interesting on here. We talked about volts, talked about current. What I find from a day job standpoint is a lot of companies now have modernized, and they may have tapped into or added on to an existing circuit. Typically, everyone does some thoughtful planning that says, can I really do that or not? And if you look at social media, there's some interesting examples of people plugging in, 30 Christmas lights into each other, and you're wondering, like, how is this thing not catching on fire? The same thing applies at work sometimes. We just, we work with what we've got. A new machine comes in, we hook it in and kind of go on. And when I use the example of like an electrical wellness assessment on an annual basis, and there's probably some simpler words you could use to clean that up with, is much like a physical for us going to the doctor each year, we should do some kind of baselining electrically with our companies. And we should be talking about this, even though it's kind of like the test you don't ever want to talk about when you get a little bit older, is like, you need to go to the doctor and you should have somebody put a power logger on your building and get a good idea, if you're getting good power or not, as really inexpensive insurance, so you're not potentially blowing up stuff in an unplanned capacity, which is almost always more expensive than having a little bit of foresight. So I'll go into some options, and the question I had earlier was how do we choose the right meter? And I'll kind of maneuver towards that direction here next. We'll call the things that are on the screen here the EKGs of what's going on. We can do power over overall. Typically, the type of designed equipment that's on a circuit may have horrendous current or voltage distortion values, basically how angry is it to operate. And in certain cases, such as a lighting LED modernization, and of course this would never happen with your current distributor with Marshall Campbell, but let's say you bought some lights from joeslights.com online unintentionally, and they weren't the best made, they weren't the best quality. So that can have a negative impact by plugging it into your electrical building and running it and be like, we just did some lighting modernization and now we're having new problems. And at times it's also gone back to what did we just change or improve recently with something new and modern, but also it's causing dirty power within your own ecosystem. Now, things happen where you've got a neighbor that is doing things, of course, legal all the time, and they're using a ton of energy from their basement with certain kind of light bulbs. That might be impacting you potentially. If you're industrially speaking, then they have welders, lasers, ultrasound welding equipment that uses a ton of energy. That if you're on the same line or feed, there might be variables to consider that why is that panel retripping? Now, recently I saw some really interesting things where people wired the breaker to never close. Like breakers are designed to open. Electrical equipment has a defined life. If you maintain it really well, you tend to have it last a long time. So that's where I believe Marshall Campbell can provide this to you is a electrical system maintenance, cleaning, testing the breakers, vacuuming everything, greasing and lubricating things. I'm a big advocate of, and usually you want to do this, of course, in a planned capacity, and it takes some time and thought that says, hey, we want to pull the plug on the whole building, and we want to really make sure nothing is about ready to fail. Now, at times, you're going to restart from a dead stop if you've never unplugged things, and things may not restart. And that's an unfortunate fact, but you have to think through, is that an okay consequence compared to running till failure, or you lose your main panel and you really have a bad day and it's going to be really, really expensive. So big advocate of a planned electrical maintenance program. Marshall E. Campbell, especially with their partners they have, can absolutely help you through this journey. And I'm a huge advocate of cleaning, maintaining, cycling breakers in a thoughtful, organized, planned capacity will be much less expensive than having an unplanned outage, especially electrically, where it's usually going to be a thermal event. Now, Fluke offers hardware to allow you to do some of this yourself. That's where we'll transition kind of the conversation. The second half of specific devices and some of the things out there. So when there's interest and there's capability and there's qualified personnel that can play with electricity in a safe way, all our meters are safe, they're easy to use, and you can get the same kind of intelligence out of this experience compared to or alternatively use a contractor that you feel is a better option. All right, put this away. Okay. Actually, there's one more I want to put in here before we get started. Try to put this one in front. There are definitely participation award points if you put something into the chat box. So if there's a question, don't be shy. Now, this is, you're going to need a magnifying glass. If your screen's not bad, it really is tiny, tiny print. But if you look in the middle, we've got, the 1732 to 38 loggers that have a display in them. We've got some loggers that have no display, which are meant for harsh environments. They can get wet with the right accessories. We step up there into the 435, which is more of a scope meter logger. So if you're really looking for some advanced intel, and then all the way on the right, and if I need to kind of jog this over here a little bit, there's what looks like a suitcase with a handle on it. I call that the flight data aircraft recorder. The Fluke 1750, 1760 is really meant to capture any type of electrical nuance that would potentially happen in your building. It takes a little bit more effort to then make sense of all that kind of data. And going back to the same question, like where do I start in this journey? Now, I'm going to close this here. This document stuff's certainly available. Just ask Marshall, your Marshall E. Campbell friend to, like, let's just set up a quick conversation. From a safety standpoint, we're a very strong advocate of how do you simplify the electrical connection to your building. And one of the ways you can do that is with the Fluke PQ400 window. So in the appropriate place, you would make a penetration through your electrical cabinet. You would hardwire this in, and this would be a door that can lock or not, where you would swing down the cover, and this would be in the outside of the panel, where the gray box on the other side of the device here is on the inside. And you can essentially safely plug into live voltage without PPE in a very safe and controlled capacity, so you don't have to pull the full skin off and get into conductors and do sometimes some scary stuff. Now, not practical for every single cabinet in your building, but maybe for the main cabinet where it is time intensive to have a contractor come in, or like you're going to see a lot of modernization in 2021, going back to that electrical baseline, which I believe is important, is get a good idea about what are you doing power consumption wise proactively compared to looking at your bill and saying, you're still paying the bill even when it rises. So the idea is like, how do we get ahead of a $43,000 challenge? So, there's a question in the chat that I'll kind of nurture here for you guys. There's probably no one magical meter that does every single thing. Usually the question would be is what kind of symptom are you chasing? Now let me go to another screen here momentarily and see if this works. And so previously I showed you kind of a chart table. Now this is more of a feature graph, but usually you'd say I want to do a load study, which would only be amp draw consumption. So it's like, hey, I'm going to use no more than 300 amps. I'm doing some wire sizing and panel sizing. I don't really care about what the power is. You can do that, even with our standard multimeter. The most popular meter we sell is a 1736, which gives you power quality functionality, and it does everything else that's also simpler. So when you hook this up, you get your voltage, your current, your distortion, your waveforms, and then as you go down the graph, is you can enable the Wi-Fi to work if that's important to you or not. Now, when I started the conversation today, there was the meter that I have in my basement, which is 20 feet below me, so to speak, in the corner. I'm running on my home network So I'm basically pinging that wirelessly. And we can do that same thing as putting a Fluke like 1736 essentially on your network, where you can then get that data real time. There's also a couple simpler ways to do this, which would be the 3540, which then goes through your network into the cloud, or you could basically do like an IP address where it's a direct point. Usually the conversation starts off with, I've got dirty power, what do I do? And I'm like, well, has something blown up, and has there been an insurance claim? And or are you going to pick a legal battle with your utility? And there's something called a Class A device, which is usually like the 435, and that's based on the accuracy of the device resolution-wise. So for a 435, let's see if I can make this screen go away. And coincidentally, it's right here, is if you're going to get in a dispute that has several $1,000s, like you think you're getting hosed by spending too much, or they're blowing up stuff in your plant, you need to bring the right tool to the party. The 435, 438 is a device we've used for a while, like in healthcare and everywhere else. That says, hey, if you go to the utility with that kind of with a log of what happened and timestamps, you're going to be in a pretty good position to negotiate. The 1750, the 1760, that calls for about the aircraft flight data recorder one. You're going to be equal or even better data than the typical utility may have in their own fingertips, where you're going to be ready for a fight and you're probably going to win. But you're going to want to bring a friend that's also got skill in analyzing and making yourself charts and graphs. Now, the 435 has a user interface upgrade called the 438-2. That's a user interface that unlocks some features where you could hook up to a motor disconnect, preferably de-energized, but it can be done energized in a safe procedural capacity. And through electrical connections, you can then dollarize and also see if that motor is, how efficient is it running compared to stated nameplate. Now, another example, packaging handling company has airplanes. They have 2 conveyor belts, same configuration, 40 horsepower motor and gearbox, 40 horsepower motor and gearbox. We had hooked up the 438 to one of them. Everything looked okay. All the charts and squigglies were where they were supposed to be. Hooked up to the second conveyor, and we noticed that the exact same application was drawing like 200% more load and torque than conveyor 1. And so we like, do we have it hooked up right? And started, questioning what we were doing. And one of the guys that had been there for a while goes, years ago we had an event. I'm like, what kind of event? He's like, and usually when a maintenance person says event, then it's like it's something exciting, or it's like it was a bad day. It's complicated. I guess the shaft bent on the whole beltway at the other end of the return, and it was causing this motor to work much harder than it was designed to do, and also using a whole bunch more energy than this one was. And they didn't realize it until we were able to again kind of EKG onto the equipment, understand like you're operating fine, or like you're very unhappy, you're just not exhibiting any symptoms or signs, like it's not smoking, it's not overheating. So the 438 motor analyzer, power quality analyzer, a lot of words, but we'll call it the 438, is a great tool to go around the plant and identify motor and loads that are inefficient. And you can then prioritize, like, we should do a more efficient motor, we should upsize the motor, we should downsize the motor. There's also an energy waste feature on that platform that allows you to quantify the efficiency of that circuit. And if you think of a glass with liquid, and let's say we shake this and there's foam or carbonation at the top, we think of the whole glass as 100% of energy utilization. The foam of the glass is the waste, or the energy is not being used 100%, which is just like someone gives you a bad pour for a beverage. This meter will quantify you have undersized conductors or wrong size conductors, like this is a really big run, wrong wire, or hey, you need to make a better engineering fix into this circuit. You may not have realized it was installed in an inferior capacity. So it really kind of goes back to, take a medical example, like, hey, you have high blood pressure, you have high cholesterol, or you have a clogged artery, you have a failing valve in your heart, much like they do like an MRI or a EKG. We're doing with a human, we're doing the same thing in electrical circuit capacity, without cutting you open and actually looking at your heart. We're like, we're just going to clip on, don't panic, we're going to stick some leads, or we're going to do an ultrasound of your heart and say, hey, you have an 80% blockage in your main artery. You may, you're going to surgery. The same thing electrically on a circuit within the building is like, hey, that may make sense why that thing's not been running as efficiently as it could. Now, let me put this away. Very often, there's a little green wire that goes somewhere into the ground, in industrial, even residentially. I'm a firm advocate. I think it's really important that even though that little green wire may not save a direct hit from lightning on your house from a bad day happening, it really does direct energy away from things like it's supposed to. So residentially, we have 1 or 2 ground electrodes that are outside our house, depending on the year it was built. The lawnmower, hits it, rips it out, it rusts or corrodes. And I know, speaking on the other side of this wall behind me, I've got about a 23-year-old house. I had the original ground stake, and coincidentally, about 100 feet down the road, not far, a lightning bolt hit the tree in the easement and backfed up into my electrical panel. And you're wondering, how did I realize that this happened? It wasn't until I was safely, of course, looking at my breakers, and there was a huge scorching area, and I'm like, what in the fluke is going on? So there was absolutely a short or a lightning strike that came through in the ground, up my wires, into my panel, and it actually came in through the radon mitigation fan that I have into that breaker, and that's the one that was really discolored. Now, no fire, no thermal event. What was interesting, there was no, what am I looking for? And I'm thinking about Rona and everybody that has symptoms and non-symptomatic. So electrically, the electrical system at my house was asymptomatic. There were no signs of any problems, no hissing, ringing, buzzing, nothing at all. And I ended up taking out the stake that was in the ground, and it was actually, you could see where the bolt of lightning had shorted out into the ground. Super interesting and cool. And goes back to the stories. I'm an advocate of making sure at least that silly little green wire has a really good mechanical connection to the ground rod at your house, thereby, basically giving you the most efficiency or the integrity of your home. And it worked the same thing. Now, in an industrial setting, the stakes are much higher. You're playing with 480 voltage. If you were to not know what you're doing, and you're going to go into a proactive, preventative maintenance type of philosophy, you guys maybe will see me a little bit better now. Get the light on my face. and you were to lift the braid of the green wire at a work environment, there is absolutely a possibility you could be immediately killed depending on what's backfeeding or coming across this conductor. Another example, somewhere in the Bay City area, went to visit a client out there, one of the manufacturers. They had just put in a new transformer, shiny green, like congratulations, the new transformer. We took the 1630 clamp, clamped it on the ground wire coming out of the transformer, and there's like 17, 18 amps going through ground, which then gives us a aha, something's not going like it should. So if we were to interfere with that connection and clean it or break it, there's a chance that someone would have been immediately killed. And I've had other webinars like this where after the fact someone came up to me and said, hey, I know someone that's no longer here because they did exactly that, which is why I bring it up. And I believe it's really, really important, is just because it's a ground wire doesn't mean it's not safe. And there still may be a potential on there, like even in your residential, if someone had flipped unintentionally the ground and neutral in a box somewhere, or you just weren't paying attention, you did it yourself, there shouldn't be potential on there to kill you. And again, goes always back to having a qualified person, but there's a lot of ways with Fluke equipment, you can get a good idea of how severe or dangerous the solution might be in an asymptomatic approach without having to cut open the patient. You're like, hey, I want to take this clamp meter, I'm going to clip it on the wire. And this is not the 1630, but as an example, I'm going to clip it on this wire very simply. I'm going to get readings. Those readings have value in meetings. I recommend an ohm reading for your ground efficiency. Usually it's 25 or less ohms is what the National Electric Code wants you to strive for. And the numbers are all over the bat. Mine at my house is about 9.5 or 10, but I did some pretty elaborate things in the ground to get to that number. Before it was like 65 or 70. And then I just completely freaked out and like, well, I have to get to 25. And my electric bill didn't go down because of fixing that, but it made me feel better that I have a fault path that is as efficient as it possibly can be. I do another webinar on the importance of grounding and a lot more fundamentals. So if you're interested in that, circle back with Marshall Campbell. We'll maybe make that our next topic if there's curiosity or of interest. But it's an awesome topic. Now, put that away. Come back to that in a second. Give me just a second to pause and grab a sip of water. We got about 15 minutes left according to the clock. Any questions from the audience while I'm staging my next thought process?
Yeah, so Phil, we had a question. What is the best meter to determine if I have bad power coming into the building? And I think you touched on that a little bit, but if you just want to quickly recap, that'd be cool.
Yep, I'd be happy to. It kind of depends. I don't know if that's a good answer or a bad answer. The 1736 is my most popular meter. And I'm trying to, there's 100 slides in this deck, and I'm just trying to catch up to a better picture, which is this one here. You can't go wrong typically getting a 1736 or the 1738 as a very friendly, easy to use, software is easy to use meter to determine if I have bad power coming to the building. Now that means a couple different things to me. And I guess I'd ask the person that asked the question, like, well, more specifically, what are you referring to? Now, for the sake of time, and you guys can answer in the chat too, of course, if you want. That means under voltage. That means over voltage, such as, okay, we'll talk about 480 as an agreed upon value. You're hitting my building with 505 volts every Thursday. Every Tuesday instead of 480, you're dropping me down to 430 on a particular phase, or you're single phasing me, which means a press happened to trip and I can't get it restarted because I'm imbalanced. I've got a neighbor that has very specific, they're a battery manufacturer or whatever they do, crazy manufacturing. RS is next door, and based on however they're using electricity, it's generating a transient or harmonics, and I'm on the same wires out front. We're going to try to finish up a couple minutes early because it's getting a little bit long in the tooth, but ask for a demonstration or more data on the 1736 or the 1738 for Marshall E. Campbell. The 435 is a more advanced version of that. So if you really want to capture a transient, you really have things that have, you've had some things break or electrically fail. You need to document specifically what that is. The 435, 438 would be that meter. Now let me put that guy away. I think I've got something else here to show you. We're going to go about another couple minutes, and then we're going to try to get you guys out of here early. Energy Analyze Plus is the software that's used for the 436, 438. Great platform. You have the chance to, make charts and graphs in the background. The nice thing I like about this is it gives you the max, the average, and min. So from a very simple standpoint, provided you just essentially follow the instructions to hook it up correctly, which sometimes takes a little bit of maneuvering. Most people I find when they install the current transducer, the CT, they put it onto the circuit upside down unintentionally, and then they've been taking reverse readings. The nice thing with the 1736 obviously is you can reverse the connection electrically and not have to reconnect it in the panel if everything's kind of buttoned up and you don't want to mess with it again. There is something we're very excited about talking about, and this goes into electrical consumption as well as just electrical health in general. I'm trying to find my feed here. Is if you're a social media fan, great. If you're not, I understand. I won't judge you. There is partial discharge. We're now able to visualize. Now this is the Christmas tree I have at my house, and we're essentially seeing the firing of the LEDs, much like an electrical cabinet may have short circuiting going on inside the panel. We're now able to basically look at the panel and say, hey, that panel's got some issues, much like this substation. It's like these connections that are showing up or glowing could have mechanical failure that we need to look into. Now, it might not be any big deal because there's a difference between corona and partial discharge. Partial discharge is where it's like tracking on the surface and it's destructing itself, and it's going to be bad if it continues. Corona, naturally occurring kind of phenomenon. Don't panic, it goes well with Lyme. The Fluke i900 is a visual ultrasound imager that can do both leak detection and also now partial discharge with the 910 model. So this goes back to, let me try to pause here for a minute. This goes back to an electrical wellness health assessment of your facility. So again, if I was to recap kind of today is like, hey, do you really understand how you're rated and billed at home? That helps you give it more of an understanding interest. And it's not terribly difficult. And if you're interested, just get with me offline or send me a note on LinkedIn. I'll be happy to get you up to speed. Typically a piece of hardware is needed to get a good understanding about what kind of bad power do I have coming in the building, or I think I've got a suspicion of bad power, but I really want to make sure I don't. 1736, great solution to kind of step into. We are very excited to have a couple new clamp meters come out. The 377 and 378 will have some power quality, voltage and current field sense capability, giving you, a really entry level into like what's going on electrically. So again, big advocate of do an electrical wellness assessment of your building on your own terms instead of when it's an emergency. Now, if you've made it this far, and it looks like all of you have that registered today, and I want to say first and foremost, thank you. I really appreciate your time today. It means a lot. I hope your family and friends and all those dear ones around you are safe, happy and healthy. You have a good holiday. For sticking it out this long, you're registered. At least we got your name and email. Now, if you have an interest in a power quality purchase of equipment before the end of the year, before 12/31, we'll get with a host, and I've got a coupon or a special incentive for 10% off anything that's power quality related up until the end of the year, which is again the fundamental of today's conversation was the importance of power quality, how to save some energy, how to save money during that, and some of the pitfalls about what things that cause an electrical circuit not to be grouchy, so to speak. Okay, so hopefully you've enjoyed our time together today. I certainly have. Circle back, and if there's interest, we've got a special thank you for you just because you joined today's session. It's only for you today. So that's all I have for you today. Have a great week, a great holiday season, and hopefully we'll see you next time. Thank you again for our sponsor, Marshall Campbell, for having us there on their Tech Summit conversation today. Thank you, and be well.
Thanks, Phil. Thanks everyone for joining today. Really appreciate it. Reach out to us if you want to see one of these meters or want to see it in the field. Phil and I can set that up to come to your facility and do some testing if need be. But everyone have a good Christmas. We don't talk to you, and we'll be in touch. See you later.